Hi students, in this video I'll be going through the basic rule of differentiation. Alright, so as you can see over here, when we are required to differentiate a function x to the power of n, okay, what we need to do is we need to bring the power in front, so the n goes in front, so you can see that n is now in front of the x, okay, and then what we'll do is, the next thing that we'll do is we'll reduce the power of x, right, by 1. Okay, therefore the power n will then become n minus 1. Alright, so this is the first basic rule of differentiation. So when you differentiate a function x to the power of n, you bring the power in front and then you reduce the power by 1. Alright. Okay, so for following this, we will be practicing some questions. So as you watch this video, what you can do is that you can pause the video and try the question first before continuing to watch the video to review your answers, right? Okay, so the question is always phrased like this, okay? Differentiate each of the following with respect to x. Okay, with respect to x means what you're going to do is you're going to d over dx the function, okay? So if the bottom is dx, right, then that is known as with respect to x, right? Okay, so the function for 1a will be to differentiate x to the power of 6. Okay, so this is a very simple question to start off the practice. Okay, so the way to present our working is to write this, okay, d over dx. So dx at the bottom because with respect to x. Okay, then bracket x to the power of 6. Okay, so like what we discussed earlier, we'll bring the power in front, so the 6 goes in front, so you have 6x, and then you will reduce the power by 1, so 6 minus 1, alright? Okay, so the answer for part 1 would simply be, for 1a would simply be 6x to the power of 5, right? So this is the basic rule of differentiation. Okay, let's try something slightly more complicated. Alright, so whenever you see a function like 1b, 1 over x to the power of 3, right? We need to prep the function for differentiation. Okay, so in order to differentiate, it must be in the form x to the power of something, alright? So let's prep this. So we know from the law of indices that if we bring the x up, okay, then the power will become negative. Okay, so this 1 over x cubed is actually equals to x to the power of negative 3. Okay, once we have put it in this form, then it's ready for differentiation. Alright, so we'll write the working. So d over dx bracket x to the power of minus 3. Okay, so same thing, bring the power in front, so it becomes minus 3x. Okay, then we'll reduce the power by 1. Okay, so this is where you need to be careful. Minus 3, you reduce by 1 means you minus 1. Okay, so that means the answer will be negative 3x to the power of negative 4. Right, so in most cases, we would like to express our answer, the final answer, in positive index. So what we'll do is we'll just bring the x back down, and then the power becomes positive. Alright, so this will be the answer. Alright, then 1c, okay, 2 times square root x. So if you recall, square root x will be x to the power of half, right? Okay, so we'll prep the function for differentiation. Right, so over here you can see that there's an extra 2 in front, but it doesn't really cause much of a problem, right? So basically, if you have an extra number in front, you just put it in front. Okay, then the power, okay, now you differentiate x to the power of half, the power goes in front. Okay, then you reduce the power by 1, means you minus 1. Okay, so 2 times 1, 2 times half will become 1. Alright, so in other words, the overall result will be x to the power of negative half. Okay, so same thing, we want to make leave our answer in positive index, so it will become this. Okay, then maybe we would like to return it to the square root form, right? So it becomes 1 over square root x. Okay, so this will be the answer. Alright, so just 3 questions to practice differentiating, okay, the basic function. Okay, let's now move on to slightly more complicated questions. Okay, so basically the only thing different between question 1 and 2 is that now for question 2, there's more than one term to differentiate for each question. right? But the same thing, what we want to do is we want to prep the entire thing for differentiation, right? So okay, 2x is there's nothing to change. Okay, then this one, okay, I'll do it in 2 steps. Square root x will be x to the power of half, right? Then plus 1. Okay, then we continue. So what we want to do is we want to bring the x up, so it becomes 3 times x to the power of negative half plus 1. Okay, then now once we are in this form, then the function is ready for differentiation. Okay, so d over dx, 2x minus 3x to the power of negative half plus 1. Right, so whenever you differentiate 2x, okay, so maybe I'll just do it by the side. What happens when we differentiate 2x? Okay, so if you will agree with me, 2x also means 2 times x to the power of 1, right? Okay, so if we bring the, based on the law of differentiation, the rules of differentiation, we bring the power in front, then it will be a 1 in front, x, then we reduce the power by 1, right? So you'll get 2x to the power of 0. Okay, but we know anything to the power of 0 becomes a 1, right? So in this case, this just becomes a 2. Okay, so one thing to remember, whenever you differentiate any function, let's say like 2x, then what you are left with, the result will be 2. If you differentiate 5x, then the result will be 5. Okay, it's just basically the number in front. Alright, okay, so in this case, when we differentiate this 2x, it just becomes a 2. Okay, now we differentiate negative 3x to the power of negative half. So let's apply law of differentiation, the rules of differentiation. The power negative half goes in front. Then we will reduce the power by 1. Alright, next thing will be what happens when you differentiate 1. Okay, so let's look over here. Whenever you differentiate a constant number, okay, for example, now we want to differentiate this 1 here, right? Okay, so we know that 1 can also be expressed as x to the power of 0. Okay, so now if I were to ask you to differentiate x to the power of 0, right? When you bring the power in front, you get 0, x, then 0 minus 1. But because there's a 0 in front and you are multiplying by it, right? No matter what happens behind, it will just become a 0. Okay, so whenever you differentiate a constant number, okay, such as the 1 behind here, what you are left with is a 0 behind. Okay, but because it's plus 0, right, then we don't have to write it out, okay? Because it's plus 0, then we don't write out, okay? Okay, so the next thing will be this. Okay, negative 3 times negative half, you'll get plus 3 over 2, x to the power of negative 3 over 2, okay? Okay, then 2 plus 3 over 2, x to the power of 3 over 2. Okay, so we have to return it to the square root form. Okay, so if you recall, x to the power of 3 over 2 can be written as x cubed to the power of half. Okay, power half will become square root. Okay, so get this. Okay, so the answer will be 2 plus 3 over 2 square root x cubed. Alright, so this will be the answer. Okay. Alright, so I hope you are still able to follow so far. Right? So the basic rule of differentiation actually is not too difficult. Okay, let's look at part B okay, of this question. Okay, part B is actually already in the form ready for differentiation already. Okay, but maybe you want to separate out the coefficient from the x term. Okay, so pi x cubed over 6 we can write as pi over 6 x cubed. Alright, so we should differentiate this. So d over dx half x4 minus pi over 6x cubed. Okay, so let's differentiate. Okay, so there's a half there. Okay, so x4, you bring the 4 in front. So bring the 4 in front. Okay, then x to the power of, reduce the 4 by 1. Okay, so maybe I'll just write out the working. Okay, then next one will be the pi over 6. Okay, then differentiate the x cubed. You'll bring the 3 in front. Then x 3 minus 1, right? Okay, so once you get familiar, maybe you don't have to write this working already now. Okay, this extra step. Okay, so half times 4 will give you a 2, then x cubed. Okay, then pi over 6 times 3, so the 3 will cancel with this, so you're left with pi over 2 x squared. Okay, so this would be the answer already. Right? Okay, let's look at part C. Okay, so part C, now you have this fraction, right? Okay, but we know that for fractions, we can always split up, okay, when there's only one term in the denominator. So this one we can split up into like this, okay, minus 1 over x. Okay, and this one will become 3x squared over x will just be 3x. Then this one, negative 1 over x, we will prep it for differentiation. We'll bring up and the power becomes negative 1. Okay, so we're going to differentiate 3x minus x to the power of negative 1. Okay, so let's do it. Okay, so the differentiate 3x, remember just now we mentioned, whenever you differentiate, let's say like 2x, right? Then what you're left with just the 2 in front, okay? So if you differentiate 3x, what you're left with is just the 3 in front. Okay, then let's differentiate this negative x to the power negative 1. So negative sign there. When you differentiate x to the power negative 1, you bring the power in front. Okay, but okay, in this case, we'll just write the negative 1. Okay, but actually negative 1, we don't have to write the negative 1. We just write negative will do. Okay, so negative x. Then reduce the negative 1 by 1. So negative 1 minus negative 1, right? So you get 3. Okay, negative times negative becomes positive. Negative 1 minus negative 1, negative 2. Okay, so the answer will just be 3 plus 1 over x squared. Alright, so not too difficult. Okay, so I hope you are getting a hang of it now, okay? Right now. Okay, next thing, differentiate a over 5, where a is a constant. So that means a over 5 is actually just a constant number, right? Then plus b over 2x squared. So let's differentiate. Okay, so this is already in the form ready for differentiation. Okay, so a over 5 is actually just a constant. So remember what happens when you differentiate a constant. Okay, when you differentiate a constant 1, right? What you end up with is 0. So this will apply to any constant, okay? Because let's say you differentiate a 5. Okay, a 5 would be 5 times x to the power of 0, right? Then you bring the 0 in front, and when you multiply, everything becomes 0. Okay, so okay, sorry here. So when you differentiate 5x to the power of 0, you get 5. Then 0 goes in front, x to the power of 0 minus 1. But because of the 0 here, 0 multiplied by anything, the overall result becomes 0. So whenever you differentiate a constant, okay, the result is 0. So differentiating a over 5, the result will be 0. Okay, for now, I'll just write the 0 here. Okay. Okay, then b over 2x squared. So b over 2 is in front. Then you differentiate x squared, you bring the 2 in front, and the power reduced by 1. Okay, so in other words, you will get b over 2 times 2, you are left with b x. Okay, 2 minus 1, power becomes power 1. So essentially, the answer will just be bx. Alright. Okay, now let's move on to two application questions to end off this video. Alright, so find the gradient of each curve at the given point. So actually, based on my introduction lesson in class, alright, you will know that to find dy dx or to find the derivative, the first derivative, what you're actually finding is the gradient function of that particular equation of curve. Right, so now let's look at question 3a. You have the curve y equals to 2x plus 1 times 4 minus x. Okay, they want us to find the gradient. Okay, they say find the gradient of this curve, right? Okay, of this curve at x equals to negative 2. So basically what we need to do is we need to dy dx to find the gradient function, and then we sub x equal to negative 2 into the gradient function. Alright, okay, so let's do this. Okay, so we have prepped this function for differentiation. Okay, this one you can actually use product rule, but because for this video we want to apply the basic rule of differentiation, right? So what we need to do is we need to expand it out to prepare it for differentiation. So 2x times 4, 8x, 2x times negative x, you will get negative 2x squared. 1 times 4, you get plus 4. 1 times negative x, you get negative x. Okay, so what you will get would be 4 plus 7x, okay, 2x plus 8x, okay, negative 2x squared plus 4 minus 4x, sorry, minus x, okay, so over here, okay, so correct, okay, so 4 plus 7x minus 2x squared. Okay, so this will be the answer. Okay, so after you expand this will be the function. Okay, so this is the function that we are going to differentiate now. Okay, so dy over dx. Okay, so if the expression is given as y equals to this, okay, then when you differentiate, you write as dy dx. Okay, so when you differentiate this 4, it's a constant, it becomes a 0. When you differentiate 7x, you're left with the number in front, so this will be just 7. Okay, differentiating negative 2x squared, negative 2. Okay, then you differentiate x squared, you bring the 2 in front, x, then you reduce the power by 1. Okay, so in other words, you will get 7 minus 4. Okay, negative 2 times 2, negative 4 x. Okay, so this will be the gradient function. Alright. Okay, so now basically they want to find the gradient at x equals to negative 2, right? Okay, to find the gradient at x equals to negative 2, what you need to do is take negative 2 and sub into this gradient, okay, function dy dx. So at x equals to negative 2, dy dx will be equal to 7 minus 4 times negative 2. Alright, so you actually get 15. Okay, so you actually get 15 over here. Okay, so what this means is that, okay, if you look at the right side over here, okay, so this is the graph of 2x plus 1 times 4 minus x. So I plotted it out using Desmos. Okay, so you can see that when x is negative 2 at this point, right, when x is negative 2, okay, if I draw the blue color line, which is the tangent at this point, negative 2, right, okay, the gradient of this tangent, this blue line, the gradient, right, is going to be 15, okay, because we have calculated that f at x equals to negative 2, the dy dx is 15, right? So this is what it actually means, all right? Okay, so let's move on to one last question. Okay, so for this one, you're asked to find the gradient, okay, the gradient, okay, of each curve at x equals to 1. So find the gradient of this curve at x equals to 1. So let's prepare the function for differentiation. So you just split it up 2x cubed over x squared minus 5x over x squared plus 1 over x squared. Okay, so this one will become 2x minus 5 over x plus 1 over x squared. Okay, so we'll put it in a form suitable for differentiation. So we'll bring up this up plus x to the power of minus 2. Okay, so let's differentiate this one now. So dy over dx will be, okay, differentiate 2x, we're left with a 2. Okay, this one, x to the power of negative 1, bring the negative in front, x to the power of negative 2. Okay, reduce the power by 1. Okay, then the next one, differentiate x to the power of negative 2, bring the power in front, reduce the power by 1. So this is what you get. Okay, so you'll get 2 minus times minus plus 5 x to the power of minus 2 plus minus, so still minus x to the power of minus 3. So 2 plus 5 over x squared minus 2 over x cubed. Alright. Okay, so they want at x equals to 1, so we'll sub x equals to 1 inside. At x equals to 1, dy dx will be 2 plus 5 over 1 square minus 2 over 1 cube. Okay, so 2 plus 5, 7, 7 minus 2, 5. Okay, so what this means is that, as you can see from here, at the point, this point, okay, this red dot, right, okay, is the point 1, negative 2, alright? So 1, negative 2, so at this point, if you draw a tangent, which is the blue line, the gradient of this tangent is going to be 5, right? Okay, so basically that's what dy dx function is about, right? So this is how you solve apply differentiation to find the gradient at each point of curve, right?